So for the next 35 minutes, I will be discussing zero to secure using open service mesh to easily reduce your Kubernetes attack surface. Before we get into the zeros and the ones, just a couple of quick notes about myself. My name is Thomas Stringer. I am a principal software engineer lead at Microsoft. The project that I'm currently working on is Open Service Mesh, which unsurprisingly I will be talking about here today. And some of the things that I've worked on in the past recently, I was a developer working on Azure Linux software, DevOps tooling in the cloud and not in the cloud, open source tooling. On a couple of personal notes, I'm fairly local here. I came down from New Hampshire, coastal New Hampshire, and whenever I'm not behind a computer, I'm oftentimes found surfing in our frigid northern New England waters, snowboarding up in the mountains, or I am a classically trained pianist since I was about 6 years old. So let's get right into it. Why is service mesh? But before we talk about service meshes, I think it's really important that we take a step back. Kubernetes is very prevalent in our digital world. Many of us, I'm sure sitting in this room, have Kubernetes as a large part of our daily operations, or at least daily thoughts, right? And this is not because Kubernetes is cool and, just a personal passion project. The data's out there. Kubernetes is everywhere. And the growth is exponential. And the reason behind this is, as a platform, Kubernetes really unlocks a ton of capabilities, and it makes our lives as administrators, software developers, IT personnel, much better, or at the very least, much more interesting. And with this platform and all of these capabilities, we inherit a level of complexity. And oftentimes with complexity, what we get along with that is a challenging environment to navigate. And one of the things that is extremely challenging, but also extremely important, which we're going to be focusing on here today, is security. Security is something that can make or break organizations. We all see it all the time. We hop on social media or on the news, and we're not surprised on a daily, weekly basis. Data breaches, bad actors, environments being compromised. And I wish I could say that we live in a world where security was easy and really good by default. Or better yet, I wish I could say that we lived in a world where there were no bad actors or people or software with malicious intent. But that's not the reality. We find ourselves in a place where this stuff is hard. Security is difficult, security is challenging. There's people that have dedicated their entire lives and their entire careers to information and digital security. And then there's the rest of us. And we are expected to understand it at a certain level, but we're really expected to make sure we're implementing this in our environments. And in the context of what we're talking about here today, are Kubernetes clusters. Because we're Kubernetes cluster operators and administrators, and we might not be those security experts. This is difficult stuff. X509 certificates, public key cryptography, PKI, TLS. And then we have application developers who are writing the software that we're running in our Kubernetes clusters, and oftentimes they're in the same boat. They might be experts of their domain or their programming languages, but they might not be security experts, or they might not even care so much about the infrastructure and the networking between those applications. Here's the thing though, Oftentimes with security, it's one of those things where we just keep punting it to the next phase or the next sprint, or we'll figure that out later. But that's a problem. That's a problem in our mindset, and that's a problem in the way we approach software development and software delivery. Because when we don't consider security proactively, then we're having to consider it reactively. Then our environments are on the front page of the news. Then our company has to notify users of a data breach. And this is not a situation that anybody wants to find themselves in. Not me, and I'm sure not you. And that's the problem. We have this perfect storm of a very complex but powerful platform in Kubernetes. We have security, which is extremely difficult, but it's not something that we can push to a later date. None of us in here can afford the cost of not doing security right. So let's see how a service mesh can help with that in our Kubernetes clusters. The first security principle that I'm going to be discussing here today is defense in depth. And I'm going to start this out by saying if there's one thing, and only one thing, that everybody in this room walks away with, I will personally, as the speaker, I will be satisfied. And that is to change our mindset from if our environments are compromised to when our environments and our Kubernetes clusters are compromised. See, because we have this human nature about us where we say to ourselves, this iPhone in my pocket, nobody cares about, I'm nobody. Nobody wants my data. Nobody wants to be in my digital world. Nobody cares. Or maybe my company, we're so small, nobody even knows anything about us. No bad actors are trying to get to us. And that's just not true. The few times that we have data about how many times bad actors try to infiltrate our environments, whether personal or organizational or professional, it's scary stuff. So I think one of the biggest takeaways here is when you go from saying if something gets into my Kubernetes cluster to when something gets into my Kubernetes cluster, it triggers a reaction that makes you figure all of this out proactively. And thankfully, we have tools out there such as service meshes that can help us solve a lot of these problems, or at least some of them, fairly easy. And the other really important thing is we have to have an answer for this, because as the IT professionals, whether we're operators, admins, software developers, DevOps engineers, cloud engineers, whatever you are, we're going to be the ones getting the phone calls. Hey, bad news. Turns out we found some traces of bad actors in the clusters. What's the problem here? What could have happened? And then we're sitting there wondering what could have happened. And that's where a service mesh can really help add security. And defense in depth is really about maximizing your strength for your surface attack area. And the thing that I think is really interesting is a lot of times when we visualize our surface attack area, we picture ourselves or our clusters or our computers or our environments in this big bubble around them. But let's try to shift that visualization from a bubble, a single dimensional bubble, to more of what I like to consider a surface attack onion. Okay, this is all about multiple layers, especially when we start adding platforms that have a high layer of complexity, such as Kubernetes. There's a lot of layers here, right? And here's the problem with that surface attack area onion. Everybody knows about and cares about those outermost onion layers. I mean, we're talking about the obvious things of, hey, Kubernetes cluster, is there public access to that cluster? Can you get to that Kubernetes cluster from the internet? Oh, wow, we got to make sure that's not, everybody's going to, all hands on deck, make sure nobody can access that Kubernetes cluster from the public. And then you're going to go to the layer a little bit deeper. Okay, well now who can actually access that? Let's only make sure, the certain engineers and the certain administrators can access that. And the problem is when you keep going deeper and deeper in those onion layers, people care a little bit less because it's harder to picture some of these issues that can arise. And then all of a sudden you start to get into that deep layer inside your Kubernetes cluster, an interpod communication. And we all say, it's in a Kubernetes cluster. Like nobody's gonna, like we don't need to worry about that network traffic within the cluster. We picture this big wall around our cluster, and it's just simply not the case. So I am going to approach this with a little bit of storytelling here, okay? So these are what our assumptions are. We have our Kubernetes cluster, and we have our software running inside our Kubernetes cluster, application pods talking to each other, and we assume that bad actors are just bouncing off of this security wall for our clusters. That's our assumptions. But if we start to shift that mindset from if to when, now we're going to start picturing something like this. Some of those bad actors are going to be bouncing off of this Kubernetes security wall, but some of them are going to gain access inside our Kubernetes cluster. And that's a scary thought, but that's a very real thought, and that's a very real situation here. Or worse, those bad actors, they get access inside of our Kubernetes cluster. What are they doing? It's really common for these bad actors to operate under a monster in the middle attack. Basically sniffing network traffic, likely phoning home with it. So now we find ourselves in a position where we assumed that no bad actors would ever get into our Kubernetes cluster, so we're sending data across the wire between our application pods in plain text, and then we get the phone call. And we find out that there's a good chance that these bad actors have been sniffing our network traffic. So let's talk about another scenario here, and something that's also very real and on the minds of a lot of people, especially recently, is supply chain, right? What you see on the screen here on the left is a really common thing that we all deal with in the Kubernetes world, right? So we work in pods, right? The base compute unit of Kubernetes. And what we know that what makes up a Kubernetes pod is one or more containers. And part of the container definition in the manifest is to tell Kubernetes, hey, I want to use this particular container image for this application pod. So what you see up on the screen is likely, for those of us that work in the Kubernetes world, that's likely a very common thing to see. You know, maybe you want to deploy some software into your Kubernetes cluster that you did not write, or that your company didn't write, or people that you know and maybe trust didn't write. But you want to run that software in your Kubernetes cluster, so you refer to it, in this case, my favorite app. And my favorite app is perhaps hosted in a container registry that you don't own. Maybe it's Docker Hub, maybe it's GitHub Container Registry. But it's something that you don't own. You don't own the delivery lifecycle of that container image to that container registry. This is a very typical scenario. But focus your attention on the tag that you see up there, latest, right? I think without a shadow of a doubt, this is the most common thing you would see all over blog posts, demos, documentation. It's the easy, normal thing to refer to a container image. And latest is typically a sliding window tag for a particular image. And usually that's not a big deal, right? So in this example here, you have my favorite app, and the developers pushed out v1.0.0, so latest picked that up. Great. Everybody's happy. They pushed out v1.0.1. I know nothing about the versioning of my favorite app, but all I want is the latest and the greatest of this application. So I pick up that version. And then I pick up v1.0.2. That's great. I know nothing about the versioning. I pull that into my Kubernetes cluster. And that is what you need to really realize, is that you're pulling those images into your Kubernetes clusters. You're pulling in software that you likely have not validated, at the very least, not the code diff between those versions. And you've opened up your front door of your Kubernetes cluster to software that you probably don't know a ton about. And what happens when a bad actor, somebody with malicious intent, somebody that gains access to that container registry or already has access to that container registry, pushes out malicious code into an updated container image? I've called that version V bad, but it's very unlikely that in the real world it will be tagged so appropriately. But that's what's going to happen. And then your Kubernetes cluster is going to pull that in. And now that code that you said would never possibly get into your cluster is going to be running in your cluster and doing who knows what. And that's really scary. And that is a specific situation, but not an uncommon one. Because with the growth of Kubernetes and the demand for standing up environments, for operators and administrators, and for software developers to be pushed onto Kubernetes without having this background and the experience and knowledge and training to know the right way to do it and the wrong way to do it, it puts us in these situations that we definitely don't want to find ourselves in. So how does the service mesh help us here? And for this particular scenario with defense in depth, one of the biggest things that a service mesh can bring to you, such as Open Service Mesh, is MTLS. And MTLS stands for Mutual TLS, or Transport Layer Security. And TLS is something we live in this world, whether we know it or not. When you go to a website, HTTPS, you are utilizing TLS at some level to encrypt network traffic. And what this typically looks like on the public internet is usually one-way TLS, okay? So what that means is, let's say I'm going on my bank's website. I really care if that is really my bank. So I am the client and I'm doing authentication to make sure I'm sending all of my credentials and sensitive information to actually my bank and not some impersonator. And that's typically what you would see in the public internet. My bank doesn't really care about who I am. I mean, it does, but it's not going to use TLS to authenticate me as the user of the bank. But when we have these isolated environments like Kubernetes clusters, it's common to want to utilize this two-way authentication with TLS to make sure the client and the server both authenticate each other before they start sending encrypted network traffic between them. This is a really common scenario with private environments where you would oftentimes also find a private certificate authority that might not be known to one of the publicly registered certificate authorities. So this technology and this idea of MTLS, it provides us with this encrypted network communication within our Kubernetes cluster. And the really cool thing with Open Service Mesh and many of the other leading service meshes is it gives you that MTLS right out of the box. And we're going to see what that looks like. So without MTLS, the network traffic going between your application pods is likely going to be unencrypted, or it's up to the application developers to ensure that is encrypted. But here's a challenge when we start to push that responsibility onto the applications and the application developers. It's highly complicated. And then we run into issues such as certificate issuance and certificate rotation. And I really love this point because certificates and expiring certificates is one of the few things that we don't have to touch or change, and we'll still get woken up at 3 a.m. with an outage. Right? And it's not just us, right? We see very large platforms running into these issues, and it's not an easy problem to solve. It might be easy on paper, but it is definitely not easy in practice. So now we can add a service mesh into our Kubernetes cluster. And the way Open Service Mesh handles encrypting this network traffic is it does a really interesting thing. It injects a sidecar container into your pods that are participating in the service mesh. And the way it does that is it patches your resources when they're created by using a webhook. So the proxy, the sidecar container that OSM and many other service meshes use is what's called Envoy. And Envoy is actually also another really great CNCF project, very powerful, worth looking into. And what we do is we inject the Envoy proxy sidecar, and then we do some work with IP tables to make sure all of the network communication for that pod is going through that Envoy proxy. Then at this point, it's up to Envoy to encrypt, and then on the other side, terminate TLS. And the really cool thing about this is this helps us to ensure that all traffic going between pods that are participating in the service mesh are encrypted. And the other really cool thing is it's entirely transparent to your application that's running in those pods. So let's take a step back a little bit, because there's a very common argument out there like, hey, I don't want to add service mesh. Like, I'm just like, we're application developers. We need to know what HTTPS is. We need to understand this. This is our responsibility. I would argue that's not really a great approach. And the reason behind that is Kubernetes allows us to not have to worry about so many things, right? That's the whole point of using Kubernetes. Because I'm sure we all remember the days before Kubernetes or distributed computing, and we needed to figure out lots of really hard challenges like scaling and stuff. Like, hey, I'm the application developer, and I have to worry about what happens when the VM dies, and I need to make sure something else is stood up. Kubernetes has made that it's there, it's part of the platform. So we defer a lot of software hosting responsibilities to Kubernetes. Why stop there? Security is a significant thing that if we can defer it to Kubernetes, which I like to consider a service mesh and extension on Kubernetes, we should absolutely do it. And the second point there is, I've said this so many times, but it's really important to internalize. Security is hard. And to expect 100% of the application developers and 100% of the software to do it correctly 100% of the time is just not the case. So being able to centralize this solution is really important. And then the last point is another one that a lot of people don't really think about until bad things happen. You get the phone call, hey, bad actors got into our Kubernetes cluster. Okay, I think the application developers are using network encryption and terminating TLS and doing what they should be doing. Okay, how do we know? Auditing becomes a huge challenge when you put it in the responsibility of multiple different software teams. In a good case, auditing is hard, but in the likely case, it's simply impossible. So I've talked about some really cool stuff with MTLS, and you must be sitting in your seat saying, this has to be so complicated to set up, right? We're passing the complexity requirement from one thing to another thing. This must be difficult. But that's the thing. It's not with Open Service Mesh and many other service meshes. With OSM, 2 simple commands, and MTLS is transparently there. OSM install, and then you add your namespace to the service mesh. And that's it. From that point on, OSM is going to be injecting those Envoy sidecars and making sure that traffic is transparently encrypted across the network. So I would like to show just a quick demo, and this demo is basically showing what I was talking about with the bad actor. So just to paint the picture a little bit, so this small, simple application that I've created, it's just 2 pods, okay, 2 application pods. The first one is a client, as you can see on the top, and all that client is doing is running curl every 2 seconds. And then the second pod is a server pod, which originally was only supposed to be running Nginx and just serving the default Nginx page, right? Welcome to Nginx, everything's working, great. But I have put in a bad actor with a second container within this server pod. And this bad actor, this is not some custom malicious code. This is TCP dump, a tool that many of us have used and are familiar with. So all this bad actor is doing is just dumping out network traffic going between, or really going to the server pod, to and from. And then I have a service down at the bottom there so that the client can talk to the server pod. So let's see what that looks like. So if we look at the logs of our bad actor, so all I did there was just dump out the logs of the TCP dump container. You see a lot of TCP dump output, but you see something really interesting there. You see the network traffic in plain text. In my case, this is a demo of showing this. So all you're seeing here is welcome to Nginx HTML, but in the real world, this is sensitive information. This is user data. This is secrets, private information. All in plain text, just with TCP dump. And this thing could be phoning home, pumping this data outside of the cluster. Pretty scary stuff. So what we can do is we can install OSM. So you can see there what happens first, and this is going to take a couple of seconds. We run OSM install, and that is going to install the bits for the service mesh into the cluster. And that includes primarily a control plane. So OSM is divided up in what we consider the control plane, which is what configures all of the Envoy proxies. And then we talk about the data plane, which is the mesh of Envoy proxies that are talking to each other. So in the next few seconds, OSM should be installed. And then what we're going to do after OSM is installed, okay, you can see it there. So OSM was installed successfully in the default namespace of OSM system. And then the second command there I ran, like I discussed before, was I added the default namespace to the service mesh. And once I did that, I had to recycle the pods so that the Envoy proxy could be injected into those application pods. And I'm just going to wait a couple more seconds for those pods to come up. Now, something I didn't show before was originally the client had a single container, right? It was curl. It was just curl. The server had the Nginx container, but also the bad actor container, the TCP dump container, so that had two containers. You can see right there with the container count, now the client has Envoy as a second container that was automatically injected. I didn't do that. That was automatically injected. The server has Envoy proxy, which is also automatically injected. So it looks like they are up and running now. So I want to see the logs of what that bad actor can see now. And if I scroll down, you can see that we no longer see that plain text, welcome to Nginx. It's encrypted. I didn't do anything. I just installed OSM. And now, when that bad actor gets into our Kubernetes cluster, I mean, it can't see anything, right? So I discussed almost entirely about defense in depth because I really believe that this is one of those things where it's the saying, it's very low-hanging fruit, right? You just add it to your cluster, and it just works. The next one I'm going to talk about, I am running low on time here, a couple more minutes, really quickly, is another security principle that a service mesh like OSM can help with, and that's the principle of least privilege. And the principle of least privilege states that everything should only be able to do what it needs to do. And we're really used to this, right? If my admin gives me access to that Linux application server, they're not going to give me root privileges, right? All I need to do is maybe create a file in a directory So they're not going to give me root privileges. They're just going to give me the ability to create files in that directory. And principle of least privilege says we should be doing this entirely, including within our Kubernetes clusters. So if you look on the left graph there, that's what it looks like by default. Maybe I have service 1 and 3 that are supposed to be talking to each other. I expect that. Like these are the applications doing what these applications should be doing. I have service 2 there. Maybe it's not malicious. Maybe it is malicious. But the point is it has nothing to do with service 3. But by default, it can talk to service 3. So now if service 2 is a bad actor or has malicious intent, it can access it. And I'm not saying it's going to get anything. Maybe things are encrypted. Maybe it's not. Principle of least privilege says service 2 shouldn't have access to that because it doesn't need to have access to that. And the way OSM handles that is you create what's called HTTP route group, and you basically define this at a layer 7 level to say, hey, here's the different paths. You can use path regular expressions, headers, HTTP verbs to define the targets. And then you define the traffic target, which says, okay, here's the destination, and here's the particular rules that I just defined that this applies to. And then the sources are what can access these destinations. So this forces me to be explicit because it's denied by default otherwise. This is really powerful stuff to make sure that we are exercising principle of least privilege. So over the course of this session, hopefully we all can agree that security is very difficult, a very big challenge. And with all of the great stuff that Kubernetes gives us and all of the scenarios that it unlocks, it's no different than everything else that we build software on top of. It has a layer of complexity, and it has its own surface attack area. And if we change our mindset from if to when there's a bad actor in our Kubernetes cluster, it'll allow us to be more proactive with it and start considering things like service meshes. And service meshes like Open Service Mesh can make this stuff a lot easier and really transparent to applications. I did add the and more there because I think it's really important to explain that service meshes such as Open Service Mesh are not just for security. There's some really cool other features with complex traffic routing that service meshes can really unlock. But I think the thing that we all need is an additional layer of security. Thank you very much for your time. I will be around after. If anybody has any questions, I'm going to be hanging out outside of the door, or if you want to chat about anything here. And I appreciate your time, and I hope you enjoy the rest of the conference.